Hello, Bachcho. Let's read the question. The question says that a horizontal stick of mass m had its left end attached to a pivot on a plane inclined at an angle theta, while its right end rests on the top of a cylinder also of mass m, which in turn rests on the plane as shown in figure. The coefficient of friction between the cylinder and both the stick and the plane is mu. Assuming that the system is at rest, what is the normal force from the plane on the cylinder? What is the smallest value of mu in terms of theta for which the system does not slip anywhere? So we will solve this question. First of all, we will see what will be the key concept used to solve this question. The key concept that will be used to solve this question will be frictional force, that is equal to mu into n, where n is the normal reaction. Now, to solve this question, we will first draw the free body diagram of this stick and the cylinder. So suppose this is the stick. Now it has a mass m. So if this is the center of the stick, weight will act downward, that is mg, and at this at the right end of the stick we will have a normal reaction acting upward. Let us call this as N1. This normal reaction will be due to this cylinder. And similarly, on this cylinder, due to this stick, there will be a normal reaction acting towards its center. And at the stick, there is a pivot on the right end, so there will be no action force on this stick due to this pivot. Now, we will see for cylinder, if we draw the guidelines for this cylinder about this point O, let us call this point O, that is pivot point. So this will be this is the stick, which is the guideline. Let us draw the guideline for this cylinder, and this is the inclined plane. So this is point O. Now N2 will be due to inclined plane, and that will also be towards the center. This will be N1, that is due to stick, and at the center the cylinder weight will act downward, that is mg, and there will be two frictional forces that will be acting on this cylinder. First will be due to this towards this direction due to stick motion, that will be F1, and second one will be due to incline, that is F2, and at this angle is theta, so towards the incline it will be mg sine theta parallel to the incline, and perpendicular to incline it will be mg cos theta. Now we will see, we will balance torque equilibrium for rod, say torque equilibrium for rod about point O, about point O, we will have N1 into, if length of the rod is L, so N1 into L, that will be equal to mg into L by 2. So from here we will have N1 is equal to mg by 2. Now this will be the normal reaction from the plane. Okay, so we have to find the normal reaction from the plane to the cylinder, that we have to find N2. So this is N1, that is normal reaction from cylinder to stick, or normal reaction from stick to cylinder. Now we will balance torque for cylinder, balancing torque for cylinder about point C. This is the center of the cylinder, point C. So if we balance torque for cylinder about point C, N1 and torque due to N1 and N2 will be equal to 0, and torque due to mg will also be equal to 0, as the three forces line of action of these three forces passes through the center. So F1 into R, where R is the length of the cylinder, sorry, radius of the cylinder, that will be equal to F2 into R. And so from here we will have F1 is equal to F2, that is these two frictional forces will be equal, is equal to mg cos theta, and 2, that is equal to mg cos theta, and 2 will be equal to mg cos theta. Now Next thing, we will see that for the free body diagram of this cylinder, this angle is theta, this angle is theta. So we will have this force will be here, it will be F2, this will also be theta, so it will be F2 cos theta, F2 cos theta. So 1 plus F2 cos theta, that is equal to N2 sin theta, F1 plus F2 cos theta, that will be, this will be N2 cos theta and this will be N2 sin theta. So F1 plus F2 cos theta is equal to N2 sin theta, and also N2 cos theta, that plus F2 sin theta is equal to mg plus N1. So, and also we have F1 is equal to F2 from rotational equilibrium. This we have find it out. So from equation 1 and 2, we will have F plus, this is equation 1 and this is equation 2. So from equation 1 and 2, we will have F plus F cos theta is equal to N2 sin theta. This is equation 3, and we have from here we will have F is equal to N2 sin theta by 1 plus cos theta. This is F. Now we have to find the minimum value of mu in terms of theta for which the system does not slip anywhere. So the system does not slip anywhere. So first we will see the system does not slip from the cylinder. So for this, sin N2 sin theta by 1 plus cos theta, that is, this is frictional force, that must be greater than mu into N2. That must be, sorry, this is the frictional force, so this must be less than equal to mu into N2, and this force can lead to slip. So from here mu must be greater than equal to sin theta by 1 plus cos theta. Now substituting for N2, from here, this is equation 4, so we will take it out N2 from here and put this value here. So we will have F into 1 plus cos theta by sin theta into cos theta plus N2 is F into 1 plus cos theta by sin theta, that is N2, so we have put it in N2 here, that multiplied by cos theta plus F2 is again F sin theta, that will be equal to mg plus N1. N1 is mg by 2, we have found it out. N1 is mg by 2, so that will be equal to F into cos theta plus cos square theta plus sin square theta by sin theta, that is equal to 3 mg by 2, that is equal to 3 N1. So from here we will have F is equal to 3 sin theta by cos square theta plus sin square theta is 1, so 1 plus cos theta into N1. Now this must be less than equal to mu N1, so that the system does not slip from load. So from here mu must be greater than equal to 3 sin theta by 1 plus cos theta, and here we have found mu must be greater than equal to sin theta plus by 1 plus cos theta. So comparing these two, we have the smallest value of mu minimum, that is equal to 3 sin theta by 1 plus cos theta. So this is mu minimum, and mu must be greater than equal to 3 sin theta by 1 plus cos theta. So this will be the answer. Hope you all understood it well. Best of luck.